We are trying to figure out what the area of a triangle is. So first, it's important to note that the area is the number of 1 by 1 unit squares that can fit inside any given shape. So first, let's look at this rectangle that we have right here. So this rectangle contains W rows with each with L things in them, or you could look at it as containing L columns, each with W things in them. So this is the definition of multiplication. So to figure out the area of this rectangle, we can take W rows times L columns. And so by multiplying these two together, we are given the area of a rectangle. So now we are going to look at, there are three different types of triangles. There's a triangle when the height is on the triangle, so like a side, when the height is inside the triangle, and when the height is outside of the triangle. So first we're going to look at the area of a triangle when the height is a side. So you can see right here the height is right here, and we're given our base B. So to figure this out, we are going to duplicate the triangle. So we have two of these, and we're going to rotate the copy to form a rectangle. So by rotating this copy of our initial triangle, we are given this orange triangle. And so we're given a rectangle. And so we already know how to find the area of a rectangle. So the area of the rectangle, we're going to take the height times the base. So our area is A equals base times height. But now we need to figure out the area of our initial triangle. And so we know that to make our rectangle, we had to double our triangle. So the area of the triangle is going to be half of the area of the rectangle. So we're going to half this area. So the area of our triangle will be 1/2 base times height. So now let's look at the area of a triangle when the height is inside. So similar to this last problem, we are going to take this initial triangle, this black triangle, and we're going to double it. But instead of rotating the pieces, just the piece as a whole, we're going to distribute the two parts of this copy. So we're going to take this part of the triangle and we're going to move it over here. And we're going to take this part of this triangle and move it over here. So now we have distributed the pieces. We have a rectangle. And so, similar to the last problem, we know that the area of this rectangle will be area equals base times height, because here's our base and here's our height. And now we need to figure out the area of the initial triangle. And so because we doubled the triangle to make the rectangle, we also know that we need to half this area to find the area of the triangle, because this triangle is only taking up half of the rectangle. So similar to the last problem, we're going to half this area. So our area of the triangle will be 1/2 base times height. So now we're going to look at the area of a triangle when the height is outside. So first, we see that the height is not completely attached to our triangle. It's outside of it. So we're going to insert this length right here. We're going to call it X, this orange part. And so now we have two right triangles. So we have this little right triangle where the height is H and the base is X. And we have this big right triangle where the height is again H, but now our base is X plus B. So to find the area of our initial triangle, this black one, the solid black line, we need to subtract the area of the little triangle from the area of the big triangle. And so because we have two right triangles, we know that the height is now a side of our two right triangles. So we know that the formula to find this area is 1/2 base times height. So we're going to insert these variables to get our two areas. So the area of the big right triangle is 1/2 times the base, which is X plus B, times height, H. The area of the little right triangle is 1/2 times the base, which is just X, times the height, which is H. So the big right triangle minus the little triangle is 1/2 X plus B times H minus 1/2 times XH. So now we're going to distribute the 1/2 in the H. So we have 1/2 XH plus 1/2 BH minus 1/2 XH. And because we have a positive 1/2 XH, at a negative 1/2 xh, those two are going to cancel out, and we're left with 0 plus 1/2 bh, which means that the area of the triangle when the height is outside is 1/2 base times height as well. So in conclusion, no matter if the height is on, inside, or outside of the triangle, the area of the triangle is always 1/2 base times height.